In section 11.4, we will look at volumes of prisms and cylinders. Prism volume formula is volume equals capital B times H. And remember, capital B is the area of the base. So we're taking area of the base times the height. In example 1, we want to find the volume of the prism. So remember, volume equals area of the base. So in our first example, that's 3 times 5, because it is a rectangle, times the height, which is 5. 3 times 5 is 15. So we have 15 times 5, or 75 inches cubed. So for volume, our answers will all be units cubed, or to the third. Number 2, we want to find the volume of the prism. Here we have a triangular prism. We know our base, but we don't know our height. And we know this length is 29 meters, our hypotenuse. So we first need to find the height of our triangle. So we can say h squared plus 20 squared equals 29 squared. So h squared plus 400 equals 841. Then solving for h squared, we have h squared equals 441. Then take the square root. We get our height is 21 meters. So now we can find our volume. Volume will be area of the base. Since our base is a triangle, that will be 1/2 times base, so 20, times the height of 21, then times the height of our prism, which is 40. So volume equals 210 times 40, or 8,400 meters to the third. Cylinder volume formula, volume equals capital B times H, or volume equals pi r squared H. Remember, H is our height, R is our radius, and capital B is the area of the base. And our base here is a circle. In number 3, it says a cylindrical oil tank has a diameter of 100 feet and is 70 feet high. How many gallons of oil can it hold? There are 7.48 gallons per every cubic foot. Alright, so it said that our diameter is 100 feet, so then that means the radius is 50 feet. And we were also told that it's 70 feet high, so that's our height. And if we want, we could label our diagram. So our radius is 50 and our height is 70. So we want to find the volume. So volume, area of the base, so pi times radius squared, so 50 squared, times the height, 70. So volume equals pi times 2,500 times 70. And we can simplify that to 175,000 pi feet cubed. And then rounding to the nearest tenth, so taking that 175,000 times pi and rounding, we get 549,778.7 feet cubed. Now the question was, how many gallons of oil can it hold? So we want to find out how many gallons. We're going to take our volume, and divide by how many gallons per cubic foot. So we're going to divide by 7.48. So dividing that, we get 73,499.8 gallons, and I'm going to round that, so that's about 73,500 gallons that will fit in that oil tank. Number 4 says a silo is a tall cylindrically shaped container and holds chopped grain for cattle feed. Which holds more, a silo 50 feet tall with a diameter of 10 feet, or one 35 feet tall with a diameter of 12 feet? Alright, so we need to find the volume of each silo to determine which one holds more. So in our first silo, it says that it's 50 feet tall and has a diameter of 10 feet. So that means our radius is 5 feet and our height is 50 feet. Alright, so let's find the volume here. So volume equals pi times our radius squared, so 5 squared, times our height of 50. Volume equals pi times 25 times 50, or 1,250 pi feet cubed. And I'm going to leave my answers in terms of pi since we're just comparing which silo would hold more. Now our second silo, let's see, 35 feet tall, diameter of 12 feet, so that means our radius is 6 feet, our height is 35 feet. Again, using same formula for volume. Pi times our radius squared, so 6 squared, times our height of 35. So volume equals pi times 36 times 35, or 1,260 pi feet cubed. So just by a little bit, but the second silo holds more. To find the volume of oblique cylinders and prisms, we'll use the same formula, volume equals capital B times H. So in number 5, we want to find the volume of the oblique prism with a parallelogram base. So remember, when we find area of the base, capital B, for parallelogram, that's base times height. We notice our base, we're given 1220, and then 16 is our height. This base would also be 12. So to find the volume of our parallelogram, volume of the prism, we'll find the area of the base of the parallelogram, so 12 times 16, and then times the height of the prism, which is 25. So volume equals 192 times 25, or 4,800 feet cubed. In our last two examples, we are going to look at finding the volume of composite figures. In number 6, we have a backpack. So our backpack top is half of a cylinder. The diameter is 12 inches, so that means our radius is 6 inches. So here is 6, which means to get our height, we would take 17 minus 6 to get 11 inches. That's the height of our backpack there. Alright, so to find the volume of the whole backpack, we can break it up into volume of the prism base and then volume of the half of the cylinder. So first we'll do the prism. Remember, volume, we're going to take area of the base, so 12 times 4, and then times height, which we found to be 11. So volume equals 48 times 11, or 528 inches cubed. Now let's find the volume of the half of the cylinder. So the top of the backpack. Okay, since it's half of a cylinder, we're going to say that volume is going to be half pi r squared h. So half of pi times our radius of 6 squared times our height of 4. And that's for the cylinder, because this would also be 4 there. So volume equals 1/2 pi times 36 times 4. So volume equals 72 pi inches cubed, which is about 226 inches cubed. Then to find the volume of the whole backpack, take 528 plus 226. So volume is 754 inches cubed for the entire backpack. Okay, I'm going to separate these two problems. Alright, and then in number 7, what we can do is we can find the volume of the entire figure and then subtract the smaller volume, the volume of the smaller rectangular prism from the inside. So first let's look at the large rectangular prism. So I'm looking at the volume for the entire figure. So remember, volume equals area of the base. Now this whole length, so we got 14 times 10, and then times the height of the prism, which is 25. So volume for the entire prism, so 140 times 25, or 3,500 centimeters cubed. Then for the small rectangular prism, so the small area inside, where its base is 6 and its height is 6, then the height of the prism again is still 25. So we'll take area of the base, so 6 times 6 times the height of 25. So volume equals 36 times 25, or 900 centimeters cubed. Then to find the volume of the actual figure, we're going to subtract the two. So take 3,500 minus 900. We get that volume is equal to 2,600 centimeters cubed.